history of the same file, you can go in time and try to track, okay, what all the changes you have made to it. The same thing can be applied to the directories, and ultimately all of your files would be stored somewhere. And it follows the version control system, which means, again, whatever changes that you are doing over the time, you can specifically go to a particular version and try to see the content or try to measure the changes that you have done there. So that's Git for you. But when I talk about Git, a lot of people have one confusion about it. Hey, I know what Git is now, but what do you mean by GitHub or BitBucket then? Or does it mean that when it is on CLI, it is Git, and on when it's on UI, is it GitHub? So basically, the main difference lies between the implementation of it. So Git is a system which can be implemented by any of the users. So you can also implement something on top of Git and put it as an offering to anybody. As an open source world, you would like to have more and more users using your implementation. So that's where you see a lot of competitions are coming up, with respect to GitHub, BitBucket, GitLab, and so on. So in general, GitHub or BitBucket or GitLab, they are hosting servers which implement Git, of course, and they offer you a nice UI to manage things. For example, you have the features like pull requests. So Git doesn't have any concept of pull requests. Rather, this implementation offer you the same. And how do they manage it? It's up to them. They also provide you issues. So you can raise an issue against a repository saying that, hey, I don't think this is working right, but can you have someone look at it? So those nice UIs, working, I'm sorry, working with respect to issues is provided by either the server hosting implementation, but not from the Git. So Git is just a version control system, which on top of you can write something as an implementation and give it to people. So that's how I try to explain to people, how GitHub or Git are different in nature. I hope that clarifies things. But still, we have this hesitation that, hey, I don't want to use Git CLI because maybe I have seen the obnoxious side of using it and then messing around with some of the things, and things stopped working, or maybe I lost my changes. I lost all the code that I had written in 7 days and now it's gone. So that's true, because personally, I also started using CLI, I think last year itself. Before that, I was using some GUI tool to manage all the basic operations like pull, push, rebase, and so on. So this motivation to use CLI was very, I would say, funny, because once I was working with my coworker and he said, hey, dude, why don't you use CLI? And I was like, personally, I'm a little bit afraid of using it because maybe I'll mess around things. And then he told me that if you don't mess around things, you will not learn, how to rectify that. And that really helped me to get started with the same thing. I mean, I do that for other things, but Git CLI was something that I didn't really want to mess up with. It's really, it can become dangerous that, hey, whatever you did for past few days, everything is gone. So maybe that kind of fear that you have, it's natural. But if you go in the right direction of learning Git and how to use the CLI, I think things can be simplified. Having said that, I think what important is to learn concepts instead of learning the commands. So if somebody say that, hey, there are 5 commands that you need to learn about using Git, that, okay, git push, pull, checkout, and all. No, you're not gonna maybe scale this knowledge. You will end up having some confusions, and ultimately you'll switch back to some UI again. Or personally, I would say my life lesson, what I have learned in a hard way, is we should focus on what instead of how. So if we really get to know the answers of what we need to do, then doing the how part is easy. How to do changes, that becomes easy, and half the battle is already done. So that's kind of a, I would say, mantra I follow in my life, and again helped me to learn this Git flow, Git CLI things very efficiently. So I hope with this session also, I would be able to provide more insights on what needs to be done or what the concept means, and then we can all contemplate about, hey, how those things will work. All right, so moving on. So now I'll start some of the pictorial representation of the things so that things get interesting. So basically, when we talk about Git, we are talking about two different things which are very important, right? We are talking about a remote repository in general, and we are also talking about a development machine or a developer's laptop, desktop, or whatever. Now, how these two things are related to each other. So remote repository is something that maybe you have created on your own, or maybe you are interested to contribute to. For example, you went to GitHub and you saw very useful framework or a library or anything. Now you want to contribute to it. So how do you do it? You basically try to get the same thing on your local machine, try to do the changes, and then try to get those changes shared with others as well, right? Uh, how these things can happen, there are many ways to do it, but we will talk about how you can make use of Git CLI to do it. So if you see this diagram, you see two big boxes. One says dev, which is representing your local machine. Another is saying remote, which is not on your local machine, but rather on the remote side of it. So ultimately, on the remote side, you have a repository, which maybe you have created, or you have you want to contribute to that repository too. So on the dev side, if you look at this box, it contains three things, and this is very important to understand that we have a working directory, we have the staging area, and then we have a local repository. So how does these three pieces like work together? We'll come to know in the following slides. So if I ask you to start contributing to a repository, so what is the first thing that you do? You will say, hey, I want those things in my local machine, right? So that I can maybe add a file or make some changes in some of the files and so on. So what we do is we do something like clone a repository. So what we do is git clone and the repository URL, and internally what does it do is it clones, or it takes all the content of the remote repository and actually puts in two places. So one is in the working directory and another is in the local repository. So all these three boxes have their semantics associated to them, and they work very efficiently with this kind of an architecture that you will come to know, or that you will realize in following slides. So bottom line is, when you do git clone, what happens in background is the files that are stored on remote repository are, let's say, copied in two places. One is in your working directory and another one is your local repository. How do we connect these two? Let's see in following slides. So once you have cloned a repository, what's the intention behind it? You want to make a change, right? You want to maybe add a new file, make a change in some of the files, or maybe remove a file. So let's try to depict a scenario here. Let's consider that your remote repository has one file in it called ls.txt. Now you have already cloned the same, so you have that change in your working directory right now. What your intention is to actually create another file, which is bob.txt. So that's why you see a plus sign in here, which represents that you have added this as a new file. Now, in order to make the intended work done, which is share this bob.txt with the rest of the world, it needs to be a multi-step process. So how does it look like, and how Git actually works with respect to multi-step things is, first of all, you have the change with you. So nothing will be directly shared with the external world. It needs to go with one stage to another and another from another. So first thing is, you need to actually put the changes from working directory to actually staging area. And how do we do it is very simple. What you do is use git add, and whatever the file name that you want to add to staging area is this. That's it. So what you do is git add bob.txt. Git takes this file from working directory and pushes it to staging area. Now, what the staging area is, it's a place in which you want Git to track all the changes, or it's a place where all the track changes are present. So right now, when you added a file in your working directory, Git internally means that you have an untracked files. Git doesn't know about it yet. But once you add it to a staging area, Git now is tracking this file. Git knows about the changes being done to this file. So this is one step to your the whole process. The other step would be to actually promote this change to local repositories, so that this guy mirrors the remote repository somehow. And how do we do it is something we call commit. So what you do is you just simply put a command called git commit -m, providing a beautiful commit message representing what exactly the change could be. What you're saying is, hey, I have added a bob.txt file. And what internally Git does is whatever you have in the staging area, it's going to make it as a commit, and it's going to push it to your local repository. That's it. Now, still the changes that you have done are not shared with the rest of the world. If you want to do that, you have to do the final process to it. Final step to the process is pushing the changes. Okay. So once you push the changes from your local repository to remote repository, it's going to be available for everyone. And how do you do it is, let's say, for simple use cases, just a git push command. So now we understand, hopefully we understand that, hey, what do we mean by running each and every command? How does one chain transit from one state to another? And yeah, that's how you do your first push. So once everything is done, you can see that what you have in your working directory is also represented in the remote repository. So that means you have a mirror copy of everything. That means like you are done. And by pushing your changes, you have pushed your changes to one of the branch existing in the remote. But I just mentioned about something called branch, and it's also very interesting concept of Git. If we understand what a commit is, we can really understand what a branch is as well. So basically, this is a pictorial representation of a tree, actually, but it doesn't look like a tree though. So what happens is we have series of commits arranged in some particular order, and we try to associate some pointers to any of the commit. And those pointers could be representing some of the things. So in here, if you see, we have, so first of all, this commit was added 25E143D. After that, we added another commit on top of this, which was 745 and so on. Then another commit and another commit. Now what we added as a pointer was this called master. That means we have a master branch which is pointing to a commit. And having said that, it should also simplify the reasoning behind the concept of branch, which is branches are nothing but the pointers to very specific order of the commits, or commits which are connected or arranged in specific order. So you see there is a commit arranged in some order, and there are two branches pointing to it. So one is the master branch and another is a branch called branch foo. And there is also another pointer, which is a helper pointer pointing to master right now. So generally, branches don't move from one commit to another just like that. What we do is we move the another helper pointer called head. So that will come later. But just for simplification of this, consider that branches are nothing but pointers to the commits. With that, let's look at the other concept, which is merge. Okay, so what's the motivation behind merge is? So if you remember the first use case where we wanted to share our changes with the rest of the world, what we wanted to do was to push one certain file to the remote repository. That works if you're working with only one branch. Consider that you're working only with the master branch, and when you make another commit, you just move this pointer from this commit to another commit. That works. But in reality, you don't work with only one branch, because you might be interested in doing parallel things, in maybe some breaking changes happening with some guy, and another one is working on some other things, which is very cool stuff. And you don't want to disturb the master branch itself, so that people looking at the master branch should only get these stable changes. Okay. So that's where the concept of branches come. And ultimately, the motivation of having a branch is that at the end of the change is done, maybe you want to merge or you want to share those changes in the master branch itself. That's being said, consider that somebody has created a branch called branch foo, which was taken off from this commit called CEBE545. And what they have done is they have added a new commit to it. So now, if you imagine this as a tree, that you have branched off something from here and added another commit to it, and now your branch is pointing to this new commit. What your intention could be that I want to merge this change, which is 270.386 commit, to actually the master branch. Okay. So when it comes to merge, there are various approaches to merge, and the most simplification approach of that is called fast forward merge. What happens is when you merge very simple changes in which you see that master pointer was pointing to this commit earlier, and you just have another branch created having only one commit. So if you ask Git to merge these changes, saying, hey Git, please merge whatever is there in my branch with a branch called master, what is Git is gonna do is it's gonna simply see if it can merge the changes automatically, and if it can, that approach is known as fast forward merge. So what it's gonna do is promote this master pointer from this commit to actually this commit, and that's it. The whole commit history follows. So master is pointing to latest commit, which is 270.386. This points to another commit, to another, and so on. So whosoever looks at the commit history will come to know that, hey, these were the changes being done on master branch, and there was another commit on different branch, but this got merged to master. So all the changes available in branch foo branch, well, it's recursive, but okay. So branch called branch foo is available in master as well. So that's really simple. But generally, it's not the reality as well. What happens is people try to work in parallel, okay, and they work in n number of branches, okay, and they will have n number of commits as well, and that's where the intercases start to emerge. So consider the scenario in which somebody created branch foo from this commit, and they added another commit, which is 270.386. Now, when this guy was working on branch foo, somebody actually merged, or let's say added a new commit into branch master. So now the master branch is not pointing to this commit, rather it is pointing to another commit, right? And this is how our real world looks like. You can't stop someone to merge something in master unless you're done. It's not natural, right? Somebody will be working on their pace, and maybe that task is small, so they will be merging as soon as they are done. So if you ask Git to actually merge these kind of changes into one, Git will be having a hard time to do it. And what we call the situation is that your branch has diverged from its original nature, because right now the tree doesn't look natural. So in order to merge the diverged branch, this is a very complex thing to happen from the Git side, but it's very important to understand as well. What Git does is, if you happen to merge these two changes into one, Git is going to create a new commit actually, which points to these two children. Okay, and now you can follow the changes, but with only one exception or one caveat, which is, now you see this guy has two parents. CEBE545 has two parents to it, like, which is 7503A404 and 270.386. And also this guy, which is a new commit Git has created called merge commit, is pointing to two children. Now, this is again a simple scenario, but in real life, you can have a lot of these cases where merge commits are pointing to, let's say, 3 or 4 commits, and you do not want to see that and maybe try to understand what's happening. So what do we do? So just like we have merge, we also have a concept of rebase. And this is the most confusing part of the system, which I have seen people making mistakes in. They sometimes forget about, hey, what the rebase is and what the merge is. But I must say that idea behind that is very simple. So merge, we have already seen that how does it work, okay? But rebase is really interesting. And what the idea behind rebase is, you really want to keep a linear commit history. Linear means that only one direction you have all the commits pointing to. And in order to do the rebase, the process looks very simple. What you want to do is you say that, hey, I have a branch which has one commit to it, but it was branched off from this commit, but I want to rebase from the master now. So master is pointing to a commit called 750.3a04. And when you run this command called git rebase origin master, what happens is Git is gonna replay your changes commit by commit after this point. So Git is gonna say, okay, I know where do you want to rebase from, which is this whole series from here to here. But in order to rebase, I will try to replay or apply your changes one by one, commit by commit after this guy. Since branch foo only had one commit to it, after Git applied its changes, it just plays that commit after the master branch commit. That's it. You see the linear history, how beautiful it looks like, and how linear history can also give you the picture that, hey, okay, I know how the changes actually are flowing in the system. Apart from that, whenever I speak about rebase and merge to people, people always prefer rebase, in their even production scenarios. They try to keep the commit history as lean as possible. Just give me a moment. I'll just drink water. Okay. So yeah, I was saying that rebase is really helpful. It gives you very clean and linear history, commit history, and this is also most preferred merge strategy, I would say, over original merge. So this is, another interesting thing, which is if you again recollect the scenario in which you happen to do the rebase, what do you do after that is push your local changes into remote, right? Now, if you try to do git push, you're going to see this kind of an error which says, hey, I can't push to remote because the changes that you have in your local doesn't look like the changes which are present in the remote. And changes doesn't mean the changes happening to the files. What it means is the git tree which looks in your local for your branch doesn't match the git tree which looks in the remote. So in that case, what happens is you can actually avoid this warning, and it's not actually the warning, it's an error. So you can't really ignore this and proceed further, but you rather can suppress this. And how do you do it is you can do git push with force, but this also has some caveats attached to it. You can use the force push by saying git push -- force, but you should also understand about the consequences it's gonna do to you. Very basic thing is when you perform rebase or merge, what Git does is it changes the tree, as we already have seen, right? So the tree looked like this, then it became this. Maybe with merge thing, with rebase, it looked like this. So it doesn't represent the tree which is on the remote side, but when you push with force, what it does is it's gonna replace the tree on remote from the tree which you have in your local. So it's very, very dangerous. If you do git force push, whatever git tree that you see in your local machine is gonna be the same in your remote. So you have to be really, really careful while doing that, because what can happen is maybe you removed the commit from the tree, and it was very useful. Now, when you force pushed it, you're gonna lose that commit. Okay, it's even you won't be able to find that in your remote. So again, a warning: when you use git push force with force flag, be very careful. So that was related to like phase one of the session, meaning how to push your changes to remote. What we are also interested in to get the changes from remote to local. So if you recollect your diagram again, we had three components in your dev, or three partition of your dev machine: working directory, staging area, and local repository. And I said that local repository is kind of a mirror of what you see in your remote repository, which is true, but it also has some of the internal representation of the things which you might be able to see now. Okay, so what happens is you have, let's say, certain branches on your remote repository. When you initially cloned it, what Git is gonna do is create two sections inside your local repository called branches and remotes. So it's gonna attach a pointer from your local branch to the remote, which says that, hey, whenever you push changes to your local master branch, it's gonna be represented inside origin master branch. So origin is the remote and master is the branch there. And this is having a connection to the master branch present in the remote repository. Similar to master, there is another branch called foo, like branch-foo, which also is connected in the same way. But if you see, when we cloned the repository, this was the case. But now somebody created another branch in the remote called branch bar. Now, how do we get to know about this guy? So there's there's a command called git fetch. And what does it do is it's gonna fetch the branches on the remote, but it's gonna update only one section of your local repository called remotes, which is that there is a branch on remote, and I know what like how do I know that branch? It's because origin/branch bar. So if you wanna learn more about remotes, it's very interesting topic as well. It can also become lengthy. You can Google it. You will really find it interesting that how can you have different or more than one remotes attached to a repository, and how some of the times I had people asking me, hey, this origin, does it mean a keyword that is that is reserved to Git? And that's not the case. You can have anything instead of origin as well. So if you do git fetch, it's gonna only update the remotes part of it, but it's not gonna give you the branches section. So if you want to, let's say you're working in master branch right now, okay, and you want to switch to another branch, which is branch bar, it will not allow you to do that because it doesn't know that this kind of branch exists. What do you do in that case? So instead of git fetch, what you do is you do git pull, okay, and it does whatever git fetch does, but it also updates your branches section. So it updates the link that, hey, there is a branch bar in your local repository, which is pointing to branch bar in your remote, and that is connected to your remote repository directly like that. So I think that's how you differentiate between git fetch and git pull. Based on need, what to do is something that you need to see. Okay. So when you do git pull, it also runs some things in the background, right? What it does is it tries to actually see how many changes that you have done in your local remote repository, and it's gonna try to merge those changes in your local repository, okay? And when I say merge, it could happen that you have 5 commits right now in your local repository, but remote has 7. Now it's gonna merge those 2 commits somehow. And by somehow, I mean if they are diverged, again, you know that git merge is gonna create a new merge commit to it, and then you will have multi-branch kind of a tree. Since we have already know, we already know that there was a rebase flag that we could use, you can also, influence this behavior of git pull that, hey, don't run git fetch and git merge. Rather, use git fetch and git rebase. So to use git rebase kind of a functionality while you're pulling the changes, you need to supply that flag. So you can say git pull ---- rebase or even -r for short. It's gonna pull all the changes from remote repository to your local, but it's gonna apply the rebase strategy to merge the changes that you have on your remote to your local. Well, that's really interesting to know, but in real life, what happens is you are working on some of the changes, okay, and you are in middle of something very important, and some of your coworkers say that, hey, I have pushed some changes, try to just pull them and see if those work for you. And this is how things can become awkward, that hey, you are in middle of something, you have your changes unsaved. How do you kind of put them in a temporary location and then pull the changes from your remote and then again try to reapply your local changes or unsaved changes? So this is where git stash comes into picture. So not some of, but most of the times these are the commands that you would use. But instead of commands, we are targeting to understand what is git stash. Okay, so the most of the times I have used git stashes. I did some of the changes which I need again and again, but I do not want them to be pushed on remote. I save those changes in a stash and I try to reapply those stash changes in my current change so that I'm done. I mean, I apply those changes directly on my changes and I do not share with them with anybody. So very basic things to do here is you can create a stash with this command called git stash save and provide a nice description to it so that when you do git stash list, it's gonna show you how many stashes you have saved and what are the descriptions to them. If you just do git stash, it's gonna create a stash for you, but the message will not be nice for you. You won't be able to recollect, hey, what does this change mean? So when you do git stash save or git stash, it's gonna create a stash stack. And for the stack, we know that the property is all the changes which are done on the latest would be the ones will be applied first. So when you say git stash pop, it's gonna take the latest or the last change happened on the git stash stack, and it's gonna apply the same to you, to your current working directory. But you can also modify this behavior saying that, hey, I want to apply very specific index of the change into my current changes. So you can do that with apply command. So when you when you apply the changes from stash to your current changes with an index and an apply command, the stash changes will also remain in a stack. But when you do pop, the changes are gonna vanish from your stack, and those would be applied to your local current state of the repository. So again, a long story short, if you are in an awkward situation where you want to temporarily park your changes, git a stash to the guy that you are looking for. Also, another interesting topic is cherry picking, which means that you want to share some of the changes, not the whole branch, with any other person. So let's consider a scenario in which you have this simple tree. Okay, it looks complex, but trust me, it's very simple. So let's see how the changes went like this. Somebody created first commit like 25E143D, then another commit, then another. And at this change, two people created two different branches. So one created branch foo, another created branch bar. While they were working in their branches, somebody also pushed change in the master branch, which is 7503A04 now. Okay. Now, it could be possible that the guy who's working on branch foo found out that, hey, he needs some of the changes, which the guy who is working on branch bar maybe is also doing. So instead of duplicating the work here in this branch, he will ask this guy that, hey, when you're done, just make a commit of it and share that commit to me. So what the intention behind that is, The changes will be done only once, and then you will borrow those changes from this branch to this branch, or vice versa. So in this example, what we are going to see is you are on branch 4 and you want to borrow the commit called A216EE0, which is, yeah, this one. So you want to borrow this commit from another branch to your branch. What you need to do is just do the simple command, git cherry pick and the commit number. The changes are going to look like this. So this commit is now represented in your branch as well, but the commit number will be different because you can't have same commit number being referred in multiple branches. So commit number is different, but the changes are exactly the same. And this is one of the most useful feature I have seen people using, to borrow the changes or maybe applying the changes from one branch to another. When they realize that if somebody was working on some bug fix and they also need that fix on their branch for the feature to be completed, they just cherry pick that bug fix from another branch to their branch and they're done. All right. Very interesting topic in Git called rewriting the history, and important and at the same time very complex to understand if you don't get it in one shot. Well, that's fine if you don't get it in one shot, but if you forget what do you want to do, then believe me, it will be very hard to do the changes with respect to writing or rewriting the history on just firing some of the commands. It's not gonna work maybe at all, or maybe you will end up having some of the unwanted state in your system, or maybe you'll end up hating it. But the question is, why do you want to rewrite the history? And I just mentioned few points which I thought people make as an excuse that, hey, I want to change something in my past commit because of this. But it could be any other XYZ reason that you want to do that. Okay, so it's not very limited to this tree, this list. Very, very often I have seen that people didn't write a good commit message, and then they have got the comment from someone that, hey, please write a good commit message so that it depicts exactly what this change would be. Or people working in multiple with multiple Git accounts, Git users, they forgot to switch the user, and now they have a commit representing another user as the author, and they want to change it. So all of these scenarios I have listed, these are very trivial, but again, these are not the only reasons why do you want to change the history. So changing would mean that you want to change either the last commit or the commits behind the last commits, or any commit that was in the past. Okay, so changing the last commit is very easy. What happens is, if you know that you are on a state in which you just committed something, or you just pushed your final commit, and you realize that, hey, there was a mistake in that commit, you can easily make the changes. What you need to do is just fire this command called git commit and a flag called --amend. What it does is it takes you to, or let me put it in this way. By default, what it does is it asks you that, hey, did you forget to put a nice message to your commit? If yes, then please write a new message to me now. So it's gonna open up a new or your favorite text editor or Git configured editor, and it asks you for very brand new commit message to your commit. If you're not interested, in changing the commit message, you want to keep the same. Either you can save the file in which, or you can just press enter, or you can just say that, hey, I do want to change the commit message. Please skip the screen. Or you explicitly specify --no edit flag, in which you won't be asked to uh, change the commit message. But what exactly do you want to change in the last commit is you forgot to add a file. So you add a file in your staging area with git add command, and then you fire git commit --- amend, and you're done. Your your past commit will now have the new file. But as I mentioned earlier, maybe you forgot to have the correct author for the commit. So how to do that is --author flag will be your uh, helper guy here. So the format is you should have your username and user email provided in the Angular brackets. And very interestingly, if you want to update the time of the commit, you can also do that. You can fake that, hey, I did that commit at this time, not this time. So you can provide any ISO 8601 format in --date flag. So very simple. Changing last commit is okay, simple, but not always you would want to just change last commit. What you are interested maybe in is changing the past history. Okay, like you want to change more than one commit, or you want to maybe remove some of the commits from your history and so on. So Git also has very nice functionality to do that. It's called interactive rebase, and it's really simple to do if you know what needs to be done. Otherwise, it can become difficult. So the way you can do interactive rebase is, like, syntactically, you can do it in different ways. Okay, so consider that you are in a branch. You have made several commits. Now you wanna make some amendments to your commits. So what you can do is, hey, get rebase from master branch, which is present on origin, and I wanna start the interactive rebase with -i flag there. So what Git is gonna do is, Git is gonna place the pointer right now on the master branch, and it's gonna replay all the commits one by one, as we have seen earlier. But with the interactive rebase flag, it's gonna show all the changes that you have done in your branch and which are not present in master branch, and it's gonna give the decision back to you that, hey, do whatever you want to do. So specifying a branch is one way to start interactive rebase. Another way is to specify how many commits do you want to go behind. So what you're saying here is, hey, wherever the head is pointing right now, I want to go 4 commits behind to that and start the interactive rebase. Another way to start interactive rebase is specifying the commit hash itself. Okay, so you can just say that, hey, find this commit ID and start rebasing interactively. So when you specify -i flag, the next screen that Git is gonna show to you would be like this. Okay, looks very big and scary, but trust me, it's very simple. So what it depicts right now is you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 commits were present in your branch when you started the rebase process in any manner, be it a branch interactive rebase, head, and some few commits, or let's say a commit ID itself. So let's say you want to rebase your changes on top of master branch, and after master branch, these are the 9 changes that you have done. But what I'm really interested in doing is to change some of the things in these commits. For example, if you see, I added a file called alice.txt. Then I added some text inside that. But while I did that, I realized that I forgot to put some important information inside alice.txt. So I made another commit providing the missing information. But ultimately, on the remote side, you will see all the changes there. But from the commit side, if you see, maybe you think that, hey, maybe if I can change some behavior on this commit would be very good. Then you added a file called bob.txt, but you see we did a typo in the commit message. not good to look at when you look things back. Then somebody actually pushed changes in your branch saying that a very weird commit message. Maybe the commit doesn't have any changes at all. It's just a dummy commit message, commit having no changes, but just this commit message. And what you want to do now is maybe to get rid of this somehow. Then you added a commit which was having wrong username. Okay, so you know now you amended this commit saying that I don't know how to change the user, but I know the user was wrong. And there was a commit that you pushed by mistake. So these are the commits which happened in order, top to bottom, for sure. Now, what our job is to do all the amendments that we are interested in. And what Git shows you is the commands that you can use to rectify those mistakes. So I think from starting from pick to fix up and including drop, these are most useful commands I have seen people using, including me. So what the default thing you see in the first column is pick. So pick means is you want to use this commit in your branch as well. Okay, this is very simple. But if you replace this pick with something called as reword, what does it mean is you want to use this commit, but you want to edit the commit message. So, and from our situation, we have seen that we had this kind of a requirement somewhere. Okay. Then we also have edit, which means that you want to use the commit, but you forgot to add some of the changes in that commit. So you want to rectify those things. Maybe you forgot to add some of the text inside the file. Maybe you want to change the author at that point of time, and so on. So if you say edit and place it in any of this commit, when Git applies these commits one by one, it's going to stop on the commit which says edit, and it's going to behave like as if you are changing your last commit. And changing the last commit is dead easy. You can just say git commit -- amend, and that's it. Yeah, and when you continue rebasing, it's going to again apply the change after that you have the commit. Another one, which is squash, my favorite. What happens is you have added a lot of commits, but you do not want those micro commits to be available in your branch. What you want to do is combine all of those changes into one commit itself. Squash is the guy that you are looking for. But when you do squash, it's going to combine all the commit messages into one. So let's say if what we were to do was we are going to squash this last 4 commits into one. So we will put squash in front of them. Oops. And what it's going to do is it's going to create a commit message having all these 4 lines separated by /n. But maybe you want to squash them, but have a nice commit message to it. So the guy next to it is just the same thing that we want to do, is fix up. So you want to combine the message, combine the commits into one, but also want to replace the commit message fully. You want to say that, hey, I do not want these combined commit message, rather it should be like this. Another favorite is drop. You do not want one commit to be part of your branch at all. You just drop it. You just say, hey, instead of pick, it's drop, and you are done. So I think after this, if you guys are with me, you should have this kind of a situation where you want the intended changes to be done. So we wanted to have the ls.txt file. We wanted to have the text inside ls.txt. But when we forgot to add few more text inside ls.txt, we do not want this commit to exist at all. What we want is to combine this commit with the previous one itself. What we want is the changes happening in B4, BB, F8E to be available inside B8C to F937 itself. That's it. So it says just one commit saying added text inside ls.txt. That's it. It has all the text what it needs to have. Then we wanted to change the commit message of this guy because we made a typo. So of course, reword. Then we wanted to have this commit called, that's why it's pick. We didn't want to have this guy into our commit history. So we dropped it. We want to drop this commit. Since the next commit is something which we want a username to be changed, we have done edit so that when Git applies all the commits one by one, it stops here. And we do git commit hyphen amend hyphen no edit hyphen author and supply the correct author to it. And last but not the least, we do not want this commit to exist in our branch at all. So if you save this rebase history or rebase specification and you just proceed further, there are no conflicts. What you're going to see, a commit history like this. And trust me, it's the most beautiful thing that you would like to have in your commit history and also in your repository, right? That each commit represents what could be the best thing that they depict happened to them. Yeah, there could be improvement with this commit for sure. That commit with wrong username might not be the correct right now. So you might want to also switch this commit message to something else, but to get the gist right. And this is where I have seen people struggling as well. They do not know when to fix up, when to revert, when to squash. And sometimes they lose commits and their rebase process go in haywire. So people avoid it with Git CLI and maybe they ask someone else to, or they don't do at all. Simple. So one caveat I would like to highlight here is when you need to do fix up or squash, you need to have a commit called pick just before that. Meaning when I did fix up in this third commit, I needed to have a commit before that, which was pick. Otherwise, it wouldn't have worked. So I can have fix up, but again, there should be a pick commit somewhere top or top of the tree. So that's one. And another is you can actually do fix up to all the commits, but you must have one commit which is pick. So that's one of the caveat using squash and fix up. All right, so that's where we have seen how can you influence the history and how can you amend your mistakes and be happy about it in the future. Having said that about history, it's also applicable for when you are working with open source projects. And as I mentioned that you can also force push when Git doesn't allow you to push because of the tree being different in both of the your local repository and your remote repository. So how do you change the history in your open source projects? So the guideline is you should not. So if you have done some mistakes, you have to live with those mistakes, because what can happen is you have a history and somebody is working based on that history, okay? But when you update the history on the someone's computer is gonna be screwed up, and they will have some commits. Maybe they are pointing to some other location which does not exist at all. Okay, so when you are doing git force, as I said earlier, you should be very, very careful. And with public repositories, you should not do force push at all. But if at all it is required to do, there is another sibling of force push called force with lease, which actually avoid race conditions. Meaning, let's say you are changing the history right now based on some commit, and in between somebody pushed a commit to the branch that you were working on. And now when you do hyphen force, it's gonna override the history and the commit that someone else pushed is gone. But if you use force with lease, it's gonna check for these kind of race conditions, and it's gonna tell you that, hey, you are trying to do force push, but trust me, you do not want to do it right now because somebody pushed the change that you might want to consider in your local as well. And the way you need to move forward in that case would be to do git pull first, take that new change, and then do force with lease flag again. Again, mentioning the same thing, should not change the history of open source repositories. But still, if you have to do it, force with lease is something that you must use all the time. Okay, so writing history is something, but you can also read the history, okay? And Git also stores each and every activity that you are doing in your local repository or remote repository in terms of a ledger, which is like commit change by change history of things, and storing those kind of changes into local commits. So how do you access those things is with git reflog command, this reference log. So it's the mechanism to store the changes or maybe read those changes stored by Git in some emergencies. So the usual use cases I have seen for reflog is you started your rebase process and you know that you have screwed up somewhere. Now you want to go back to the time where you started your rebase at, okay? So if you just do git reflog, it's going to show the history of each and everything that you did, including git rebase when it started, git rebase when it was aborted or finished, and so on. So you can take that commit ID and just do git reset at this point. What git reflog is very interesting to use for is also with respect to timed reflogs. You want to see that how many changes that you have done since yesterday. So hyphen since flag, if you specify with git reflog, it's going to do the trick. So again, one of the very useful feature, if you know what to make use of it, and how is very simple. You just go to the documentation of git reflog and learn what different flags you can make use of. And yeah, then you're done with that. So with this, I think I move to the closure of the session. And at this time, I would love to take any questions if you have.
Thank you, Rahul. Any questions? Please go ahead. I have one question regarding the reflog. So does it have the log for force push? If you do force push, does it save that as well?
It depends. So based on different configurations of Git, it may and may not be there, because force push is like you are overriding the history with all the things that you have in your local. So it might also lose the commit. But again, that's being said, if you can try it out and see if your machine is or your Git setup is supporting having also the commits which were lost in force push.
Thank you. Anyone else has any question? Please go ahead.
Hello, can I have a question?
Yeah, go ahead.
So regarding merge, like what is the difference between move fast forward and fast forward moves? Can you do that? And thank you for your talk.
So if I understood your question, so you wanted to know the difference between the fast forward merge and the normal merge?
Yeah.
Okay. So fast forward merge, as I explained, was when Git is able to recognize your changes and it's able to merge those changes. And by changes, I mean commit. So if it is gonna merge commits based on the history or based on the commits happening on the branch itself, if it can do it on its own, it's gonna, the name of this approach is fast forward merge. That means if the master branch that you're trying to push your changes to right now, according to this diagram, has not diverged at all. So nobody has made any new commit to this, and you wanna merge your commits from your branches to master branch, Git is gonna make use of the strategy called fast forward merge, and it's gonna just move the pointer from this commit to the commit that you just have added to your branch, and now it's part of the master branch as well. So this simple approach of Git merge is called fast forward merge, when Git is able to merge the changes on its own. But having a complex scenario in the picture where the branches were diverged, it's not very simple for Git to identify the changes, because Git doesn't know which could be the master, the parent, and which could be the children, potential children. It's gonna ask you maybe, or it's gonna create a new commit, and it's gonna point to all the children which could be there. So this is not very simple strategy to use, and Git. Uh, so this strategy is not fast forward merge, rather just merge, I would say. And in this strategy, there would be a new commit created called merge commit. And maybe you have seen that when people merge pull requests in the repositories, it creates a new merge commit having all the changes done in the branch also being done in the master branch as well. So you copy all the commits from your what do you say, master, the feature branch to the master branch, and also a new commit called merge commit, which actually representation of connecting these two trees together. Does that answer your question?
Yeah, thank you.
All right, thank you.
There's one question on chat. Can you give some tips on any shell Git configuration that helps in Git CLI workflow?
Yeah, of course. One of the thing that I like with Git CLI is it has something called as hooks. So before you do any operation, which is git commit, git push, and so on, Git has some hooks associated to it. That means you can hook your implementation before and after some of these events. For example, let's say you are Go developers. You are writing some of the code and trying to commit those code into the repositories. Okay. Now, Go has a very good linter, formatter, and you can also do, let's say, your code quality check and all. So what you want to do is you want to have all the changes in your repositories which meet the criteria of all these things, like the code is formatted, the code is linted, and so on. What you can do is you can make use of Git hooks to run Git lint, sorry, not Git, Go lint, Go format, and so on before actually you commit to the repository. So you can Google about Git hooks, but in short, if I have to say that is, whenever you clone a repository in your local machine, Git is going to create a hidden folder called .git. Inside that folder, there is another folder called hooks. And in that folder, you would see a lot of sample files, which are bash scripts in Linux systems. So those bash scripts, if you rename those from sample to just bash or sh, they would be invoked whenever Git does any operation. For example, if you rename uh, before commit or before push file to its own shell script, that shell script is gonna be fired as soon as you do git push, and before the changes are pushed to the remote repository. So now if your script returns status other than 0, the push will not happen. So your changes will not go to remote repository, and you will have a very nice workflow in which you prevent making some of the mistakes that you might have to investigate your time in future. So I really like that feature, and it's gonna maybe help you also in your development environment to increase the productivity maybe. So that would be the tip I would like to give.
I think there's one more question on chat. Can we squash and reward top commit at once? I don't know if I understand the question, but Rahul, can you answer
Sure,
that?
I'll move to this slide. Okay, so you wanna reword and squash, like perform both.
Yeah, that's the question.
Okay, so when I started this session, I said if you know what needs to be done, then how or answering how would be easy, right? So if we understand what do we mean by having a squash and reword, then it should be clear that whether it would work or not. Okay, so the motivation of squash and reword would mean that you want to squash multiple commits into one, and then you want to also change the commit message. But if you see, to do these two things into one, there is another guy called fixup. So if you just use fixup, it's going to do the same thing that you wanted to do with squash and reword. So maybe reword is fixup is something that you are looking for to do those things.
Thanks. That's message. Any more questions? I have one last question.
Sure.
So if you have to revert a merge, like let's say I merged something in the master and I have to revert it. So if it's a normal merge, I could just like revert that commit and it would revert that. But in case of rebase, how would that? How can we do that?
So revert from Git is also a commit to it, right? So if you just consider, let's say this example. Okay, let's say you're right now a master is pointing to 27T3866, okay? And then you realize that, hey, you didn't want to have this chain in your repository at all. So what you do is you do git revert and this commit message. So Git is not gonna remove this commit from your history. Rather, what Git does is it's gonna create a counter commit to this commit. This commit will be having another parent to it, which will be having changes reverted back to the original state where which was present in maybe up till this point, but it would be a new commit. So now rebase you can have on top of that, which follows the same procedure that I explained earlier. So I mean, just to answer that question, rebase and revert would be two different operations. What you need to know is what revert does and what rebase does, and when do you need these two things. So revert will create another commit after your original commit. The changes will not be there in your remote repository, of course, but in your commit history, if you see, first you'll have the plus changes and then you'll have a commit representing the minus changes. Now rebase on top of that can work in the original fashion. How does it work?
Thanks. Any final questions?
So I wanted to ask, what is the difference between if you are on your own branch and you want to push your branch for merge request or pull request, and what's the difference in that scenario for merging the master branch with your own branch and rewashing your branch with the master branch after pulling the changes from the master branch?
Okay, I think I barely understood you because of the voice was breaking, but let me rephrase what I could understand. So maybe you were asking about what's the difference between having a feature branch and master branch scenario where you want to merge changes from feature branch to master with the merge strategy, and what would be the difference with the rebase strategy. Was that the question?
Yeah, if I'm in my own feature branch and if I want to merge from the master branch or versus releasing from the master branch. So what's the difference? So, thank you.
Yeah. So again, if you have, I'll just go to this diagram again. Yeah. If you do just merge of your feature branch to the master branch, okay, what it's gonna do, what Git is gonna do is take all the commits available in your feature branch and placed side by side with master branch, starting from a point where your branch was, branched out. For example, you had your branch started from this commit called CEV4545, okay? Now you did a lot of commits. So you had 270, 386, and so on, so many commits after that as well. So that's where your branch is pointing at. When you merge your branch with master with merge strategy, what Git is going to do is something like this. It's going to create a new merge commit and have your commits available in the series right beside master branch. So you will have all the, that linear history of commits in your branch like this, and up till some point where your the branch pointer is pointing to, and there will be a new merge commit created like this, which will be pointing to the current state of the master and your branch pointer. But if you had done rebase, it would have looked like this somehow, that let's say this was the master branch and you had 5 commits. So all those 5 commits would be arranged in the linear fashion just after the master branch itself. So if you look at this kind of representation in the merge strategy, it's gonna be a multi-branch kind of a tree, but with rebase, it will be a linear tree. Linear something that is a tree but doesn't look like a tree. So maybe a linked list, maybe. So having rebase done there would mean that you will have a linear commit history, which is neat and clean, and you might want to understand, okay, this commit does this commit does that, and yeah, you don't have any confusion about it when you look at the commit history. So up to you, what do you prefer? What kind of strategy do you prefer? If you prefer merge over rebase, that's fine, if that suits your use cases. But just a guideline from the industry, as per my experience, people always prefer rebase over merge. So does that answer your question?
Yes, I do prefer reverse over merge too. Thanks.
Okay.
I guess that would be the last question. Thank you everyone for attending. And yeah, there's this t-shirt raffle provided by JFrog, and I'd like to thank JFrog for that. So do check out the chat if you haven't done that yet. And thank you, Rahul, for the amazing talk. A lot of takeaways. I used to use Git, but uh, I have like done some of the things wrong way, and like now I learned and a lot of takeaways. Thank you so much. Thank you, Ari, for connecting and for this presentation. Thank you.
Good to know. Thank you, guys, and take care and be healthy.
Thank you. Thank you. Bye.
Thank you.
Bye, everyone.
Bye bye, everyone.
Bye.